Whew! It has been a while since I've worked on this 60 clone board. It's good to be back at the workbench, especially now that the weather's getting a little cooler here. I have got a massive box of parts that I need to get sorted out and installed on this board, and we will get after it. Coming up. Oh, and before I forget, all that stuff below the belt, the like button, the comment area, the join, the subscribe, ring the bell, all that stuff you guys are familiar with. YouTube absolutely requires me to ask you this, and if I don't, I actually get yelled at, and I don't like getting yelled at. So I just want to pass the message along. Total pressure from YouTube, no pressure to you guys. See you after the break. It has been a minute since I've gotten into any of this stuff. We got a lot of packages in the mail. This ought to be an awesome video. At least I think it will be, because I get to put all this stuff together and get that much closer to getting this thing built out. First up is a box from Commodore Forever. Let's see what's in here. Bubble wrap. Bubble wrap's always fun. This is the Shuriken, which is an RF modulator replacement for the Commodore 64. Pull out your old RF modulator from number 6, the broken box. Complete with some, I don't know if you can see those, complete with some circuit traces still attached to it. Drop this guy in. There's a little bit of a size difference there between the two of them. And now you don't need the RF output module, and you don't need to worry about that mess. Let's get that off the table. Next is a package from the Czech Republic. This one is the ARM SID. And the ARM SID is a SID replacement. Very, very, very nicely done. This is actually silk screened onto a little circuit board, which is then attached into a chip socket. And if you can see, there is the ARM chip down inside. Lighting's not so great on that. Yep, there it is. I've run the SwinSID Nano. That works out pretty well. This is supposed to be a little bit different module, so I wanted to play with that. And then a great big box from Mouser, filled with a great big lot of parts. So let's get after that. Let's see if I can do this without killing myself. Probably not. Okay. Put the ARM SID over there. Put the Shuriken over there out of the way. And let's see what we got. Capacitors, transistors. I'm just going to do a real quick sort of these. Capacitors, crystal, voltage regulators. I could have just looked at that instead of reading the package. Capacitors. Capacitors. There's going to be a lot of capacitors. Capacitors, 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 capacitors. What is this? Ferrite beads. So this is probably another, yep, 74 series logic chip. Capacitors, capacitors, inductors. I'm running out of room here. Capacitors, capacitors. Dual precision timer product. I was going to say this must be the 555, and it's actually on the Commodore 64. It's a 556. 556 is just a 555 with an extra timer circuit in it. So I'm going to put that with the other IC. Capacitor, Zener diodes, dual flip-flops, and that'll come in handy when I go out on the boat. Put that with the other ICs. Another capacitor, another capacitor, another Zener diode down here. Vichy rectifiers. Stick that there now that we have room for it. Some transistors, central semi-bipolar transistors, when bipolar is a good thing. And another inductor, which goes down there. Alright, that is all sorted out. Let's find some place to put this stuff, because I'm going to leave it in the bags. Instead of putting it in my muffin tray, I'm just going to leave these in the bags because the bags are all labeled with exactly what they are. So let me get that taken care of, and we'll be right back. Okay, now that we got that out of the way, there are also some additional parts that I needed that came in that I didn't have room on the desk left to share. This is a 6567R9, which makes that a VIC chip. These are some 104 series capacitors for pull up on the chips. The one broken inline package resistor that came in. For another repair job that I actually had some spares left over for that, so we will need one of those. Oh, missed. Empty bag. These are some header pins that I will use in a variety of places all over the board to solve other problems. Some more chips that I need, 8701, 74LS08, 74LS373, and some ROMs. And we have some sockets somewhere that I can put in for those ROMs. This is a 4044. And then all the other parts that we had from before that we were missing. And I wonder if this I already pulled out of that envelope and is the same as this. And it is. And the power switch that came in. So let's get to it. Okay, since we already have a bunch of chips in sockets, I'm going to go ahead and add chips into sockets, because it's not going to change the profile of the board all that much to worry about. This was taped up inside. Back to the old pocket knife. One down, 9,000 more to go. This is the 4044. .4044 was from Dave Surplus Electronics. If there's anything wrong, please email him. If it's all good, please leave feedback. So grab that off of eBay. No ROM sockets yet, so we're not going to put ROMs in. And a 373. Where does the 373 go? 373 does not go. What else do we have? LS08. Do I have all my 08s in? I have all my 08s in. Alright, and the 8701 is for a different rev of the board, so that takes care of all of those guys. Yeah, no, probably not the right tool for the job. This is a 74LS74. Where do we put that? Right up here. Looking at the chip and looking at the socket, the chip looks a lot bigger than the socket is. So it would not have been my first choice. Straighten those pins out a bit. And I just lay them on the desk and sort of roll it into shape. Some people use pliers. To each their own. As long as you get the job done, that's all that really matters. This is going to be the 556 timer. Nope, need to roll these ones over too. And this is a 74LS193. Where does that one go? Right there. Alright, I'm going to start a grocery list of the things that are missing, and I've been getting some emails from Mauser saying that some of the things are back ordered, so that's probably what's going on there. So I need, right now, what I don't have is 2 sockets for the ROMs, and I do not have a 74LS629, and we'll keep right on moving. Let's get this resistor pack in while it's sitting here on the bench waiting for me. So I've been waiting for a couple of weeks now. Let's see, what do I want to do with this? Tin the tip of the iron. The writing and the dot goes towards the pin number 1, which is identified by a square on the board. Stick that through the board. Grab a spare piece of tape to hold it in place. And even on the back side, it is labeled with a square via instead of a round via. Is that still a via, or is that just a place for a circuit to go? Alright, we've got one in. Pull the tape, see how it looks. Looks good to me. Alright. The cool thing about having all these parts is I don't really need to check them off as I go, because they're just going to disappear. but I do need to find where they go. So this is an 1.2 microhenry fixed inductor. And inductors look a lot like resistors, but if you look up the color codes, you'll probably find something different going on. Let me pull up the website that has the parts locator on it and start finding out where these things go. Okay, my parts locator website tells me this goes at L5 up here in the corner, which makes sense. So I'm going to fold the leads over so it fits into the holes in the board, and I'm going to check the orientation of other resistors and such and try and line it up aesthetically pleasing. And where are my big tools? There it is. I'm just going to use the pliers on here just to tug it through gently. And it went through a little too far on one side and not far enough on the other. There we go. That lines up nicely inside the square box. Doesn't really need to, doesn't really matter, but it looks pretty, and that's what matters to me. What's in this one? An RF choke. Yeah, marrying two hobbies all at once. 2.2 microhenry RF choke. And it's a bag in a bag. These Mauser guys. Belts and suspenders all the way. Alright, so 2.2 microhenry. Let's look up where that goes. Down in front. L2. Well, let's try putting it in that way. Alright, some transistors. And they rolled the edge of this bag up. These are 60 VCBO and 50 VCEO and 5 volts, 2 SC1815. Alright, I ordered 4 of them. Q1, Q2, Q8. So I got a long way to go. Q7. So I found 4 holes, but the numbering's a little weird. Alright, that was all of them. That was just, they just decided to name and number them weird. And these pins are real close together, so I'm going to need to bend some out and bend some back, because they don't fit in the hole well as they come. But that's pretty normal. So let's get in there, bend it out, bend it back. Bend it out. Well, one leg looked great. Alright. Looked like I almost knew what I was doing on that first one. Then I totally gave it away on the next one. There is a silk screen on the board that gives you kind of a layout for how it's supposed to look. So if you can see this on camera, it is a half moon type shape. And then there's a half moon type cutout on the silk screen. Cutout's the wrong word. And what I want to do is get something under there to hold those pins up. Let's try a different technique for putting this one in. Yep, that worked better. And I would be personally concerned about putting too much heat into these guys, so I'm going to do them in kind of a round robin fashion. A little bit of solder on the tip, solder on the leg, solder on the tip, switch devices, solder on that leg. Still some solder left on the tip, so I'm going to switch devices, solder onto that leg, still holding strong there, switch devices again, switch devices again, switch devices again. So I'm not terribly panicking about the whole process. I don't feel rushed or anything. I'm just aware that I want to be concerned about putting too much heat into the component. And you could probably do them all in a row without any big concern. I'm just being overly cautious. And let's put this one in here. And I like that these are all laid out on the board in the same orientation for aesthetics. And there's only one that I'm working on here, so I will take a pause in between each one. And there's an adjacent solder joint there that I don't like. Okay, trying to orient the 2 different sides of the board. Just going to touch that up. And that's why I don't like that, because it's not actually a solder joint, it's just a blob. So what we'll do is we'll make sure that hole is open for when we go to put that component in. And that's where a capacitor goes. Okay, perfect. Alright, last transistor. So I tried in the beginning to just bend the legs over nice and neat with a pair of pliers and be all precise and skilled about it, and apparently you just don't even need to do that. Just put it in and kind of gingerly send it home and solder it in place. And I went a little bit faster on that. And what I want to do, those two lower pins look like there might be a solder bridge there, so I'm going to get out my danger glasses. Everything looks good. The solder mask has done its job, so we're good to go there. Alright, 4 transistors in. What's next? Voltage regulator. And this is a 7805. And there's 1, 2, 3 places for these guys to go, so I'm going to make sure I get the right place. Alright, this is the one that goes down here, and this is the one that gets the big heatsink with it. It's keyed so that it only goes into the board in one direction, and then you put that on, and it folds down. And there's a pretty high profile on that, but it's the same profile as what's on the capacitors. So I will let that go. See if I have some thermal paste. And this is some Arctic MX4 thermal paste. Just a little bit there, and then it went all over the place anyway. And just a little bit there, probably a little bit too much. And what your thermal paste is there for is to seal up any imperfections between the two different surfaces so that you can transfer heat well. Alright, so I've got that lined up. Let me see about screws. I don't think this was screwed down on the old board. It's probably way too big. Yeah, I'm going to say that's way too big. I will dig up some screws later. I promise I'll dig up some screws later. And then this component takes a little bit longer to heat up because it is actually designed to dissipate heat, and it is doing a good job of dissipating heat. Yeah, I will find a screw for that for sure. I think I know where some are, but it won't matter if I wait a little bit. Next, Vichy rectifiers, 2 of these guys. Let's find out where these ones go. These are CR5 and CR6, and they're supposed to be 1N4001. So pull out the danger glasses and check them out. And that is what they are. And they go on CR5 and CR6, which are down in there, in between the large capacitors. And these guys have a direction that they're polarized in. They only go in one direction, but I am not sure by looking at them, so let me figure that out and come right back. Alright, so diodes will transfer energy in one direction, but not in the other. And on the board is actually the, so I can get some good lighting there for you. Silkscreen has the actual schematic symbol diagram for that. And what you want is the part of the diode, part of the transistor that has the collar on it on the part that it's pointing to. For technical terms, that would be the anode on the non-collared side and the cathode on the collared side, and the cathode goes on the, let's see if I can use this as a pointer. The cathode goes on the blocked side with the square circuit board, the square circuit connection. So we'll get both of these guys in. And these have a little bit thicker legs because they're designed to deal with a little bit thicker power. So I'll just gently wiggle these guys into place. There's one down. And this one here, I'll try a different technique. I'll try bending the legs over and see how I like that one better. Nope, I made it too tight. It'll be fine. Alright, there we go with that. Let's solder these guys home. That one's up a little higher than I wanted it to be, but that's okay. Part of the story. Alright, Zener diodes. They wanted to make sure that you never got into this by putting 2 stickers on it. This is a 1N755A Zener diode. Let's go find out where that goes on the board. CR2 right up in there. And again, this is polarized. And again, we are going to put the cathode side towards where the schematic symbol shows that this is a Zener diode. So a regular diode will have your greater than sign and a solid wall, and your Zener diode will have a greater than sign and kind of a curvy wall. Let's put that in there. I'm going to spend a little more time on that because I just want to. It's a little better centered. It was off on one side, but I just didn't like the way it looked. Right, and more Zener diodes. What do we have on this one? This is a 1N4371A. Let's figure out where that one goes. Down here in the middle, CR1. Alright, that one looks good. I thought that bag was empty. It's hiding up here. 220 picofarad, 50 volt, 5% tolerance. Where does this one go? This one is C999, the 999th capacitor that goes on this board. There's probably a number jump in here somewhere. And this goes right next to this R38 resistor, and the solder points on the board are actually touching each other. And what I did there was I applied a little more heat to get the solder to come all the way through the board to make sure there's a good solid connection. Because on the one side the solder did not go through the board, it just kind of stayed on the bottom. Multi-layer ceramic capacitors. This is a bag wrapped in bubble wrap in a bag. Oh, it's a bag inside of a bubble wrap bag inside of a bag. And there are 55 of these. So we're going to speed right on through this. Okay, so that is all done. 55 capacitors soldered on, one left over. So the question is, did I miss one? Did I get an extra one? Did somebody count wrong somewhere? Could it have been me? Could it have been Mauser? Could it have been anybody? Yes to all of those questions. Probably me. That being said, I have checked this board 4 times now looking for additional capacitors and couldn't find them. Lessons learned. This board's been sitting for a couple of weeks while I've been waiting for parts to come in, and it has gathered some dust because this is an active workshop and there's lots of projects going on here. And life produces dust. And dust doesn't solder very well. So I tried a couple of different techniques. I'm fairly confident that I do have good connections, and if not, I will know the first thing to check when it haunts me in the future. So what's the secret to getting 55 capacitors installed? For me, I just parceled it out into different sections of the board. You might have been able to pick that up on camera as it was rolling past. But it's not a big deal, because what will happen is you will wind up with an extra piece that will go in the extra pieces section of your project, and it will be a lot easier to find empty holes when there are no longer things to put in them. And, as the old saying goes, how do you eat an elephant? The answer is, one bite at a time. So, you just kind of got to get after it, and that's what I did. Alright, let's see what's next. Alright, video number 8 in the series, in the bag. 55 capacitors. 55 capacitors. That was a lot of capacitors. But we ate that elephant, and we will be ready to jump onto another part. I still have a lot of parts left from that haul, and they'll be coming up. So stick around for the next video in the series, and thanks for being awesome.